Lesson 2, related events. Fancy schmancy terms. Again, there's going to be some terminology. I snuck some of it in lesson 1, but your teenagers, repetition helps. I find it helpful to repeat things. Sometimes for teenagers, repetitiveness can be an asset. See, I did that 3 times? Okay. We're going to define sample space. We're going to talk about not A or B, and A and B. I have snuck some of this in a little bit in the last unit. You are going to find that and usually means multiply, and that or usually means add. I can't say always, but usually. And we're going to introduce something called a Venn diagram. So I wrote down here, definition, a list of all possible non-overlapping outcomes of an experiment is called a sample space. For example, suppose we select one bill randomly from this pot. What's the sample space? What are the possible outcomes? Usually we use a capital letter S for sample space. And then usually we use the funky curly brackets. And we would say 0, 5, 10. Those are the possible outcomes. I know, but it lets me have you lose, right? Something that's a little more close to home. Hey, what would the sample space of a deck of cards be? 4 suits, ace through king, or 2 through ace, or 52 cards. I'm not going to list all those. What's the probability that we select the $5 bill? We said last day that most of us have a fairly basic intuitive understanding of probability. What's the probability of a $5 bill selected? 1/3. But we noticed as soon as I asked you the the 2 girls question, our guessing was completely off. Nobody guessed the right answer. So this is why, again, people are so bad at gambling. This is why people are so superstitious. We really don't understand anything even remotely halfway complicated when it comes to probability. We suck at. It's got to be really basic. But the basics, I would write it like this. Probability of 5, 1 success, 3 outcomes. If they asked for the odds, Christina, 1:2. 1 success, 2 failures. Example 2. One bill is randomly selected from pot A and one from pot B. Part A says use a table to construct a sample space. Part B says use a tree diagram to construct a sample space, which is easier. We're going to have 2 strategies. Sometimes we're going to construct our sample space with a table. I prefer a tree. The only problem is the trees get pretty wide pretty quick. For example, if you're doing 2 dice, how many outcomes are there for the first dice? 6, and then each of those 6 branches will have 6 branches. You know what? I'm not going to use a tree for 2 dice. I'll set up some kind of a table. So we're going to do both here. Draw a little line down the middle. The table would look like this. Hey, wait a minute, Mr. Dueck. You can actually insert a table like this, can't you? Yes, I can. So I can do mine in typing, which will be a little clearer, I think. If I click right there, if I go insert table, I think I want a 4x4 table if there's 3 things, because I want to go like this. There is pot A, and you can get a 0, a 5, or a 10. And, Mr. Dueck, you need to add a row. Right-click, table, insert below. Here is pot B. You can get a 0. You know what, Mr. Dueck? Handwrite the table. This was a dumb idea. Let's try this again. I would go like this. So we have pot A, and you can get a 0, a 5, or a 10. And then there's pot B, and you can get a 0, a 10, or a 20. And the possible outcomes, I guess, are 0 from A, 0 from B. Oh, sorry, B doesn't have a 0. B has a 5. Good gosh. Read this properly, Mr. Dueck. Thank you, Tiff. Sorry. 0 from A, 5 from B. Good gosh. And you can get a 5 and a 5. You can get a 10 and a 5. You can get a 0 and a 10, a 5 and a 10, a 10 and a 10. You can get a 0 and a 20, a 5 and a 20, a 10 and a 20. How many outcomes are there? How many outcomes are there? 9. Okay? And the sample space would be 0, 5, 5, 5, 10, 5, 0, 10, 5, you know what? That's good enough. I'm not going to rewrite the sample space. You could also get there with a tree. You could start out by saying pot A, and pot A has 1, 2, 3 possibilities, 0, 5, and 10. Right? And then you could have another row for pot B, and pot B has 1, 2, 3 possibilities, 1, 2, 3 possibilities, 1, 2, 3 possibilities. 5, 10, 20, 5, 10, 20, 5, 10, 20. How many branches are there in the bottom row? 9. How many outcomes are there? 9. I kind of like the tree better, but again, can you imagine if instead of pot A and pot B, we had dice A and dice B, you'd have 1, 2, 3, 4, 5, 6, and then from each of those you'd have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, you'd have 36 branches along. That gets a little unwieldy. In fact, for dice, I always use a table. But Roy, we said if you can count it, you can solve it. And here's what I mean. Now that we have our sample space, we can answer B. Roy, can you read B to me, please, my friend? Okay, so I'm going to write probability that the sum equals 10. With your pencil, circle in the sample space in the table which ones add to 10. That one. That one. Oh, I think that's it. Yes? What's the probability? 2 out of? Yes. What are the odds? 2 to 7, but I'm going to de-emphasize that. Yep. You need to watch the last lesson. I did. So the odds are 2 that add to 10, 7 that don't. Odds are not probability. Odds are how many successes, colon, how many failures. 2 ways to succeed, 7 ways to not succeed. 2 to 7. Okay. What if I had used the tree? Well, with the tree, I would have gone like this. For trees, I tend to use check marks. So for a tree, I would put a check mark under that branch, because if I walk down that branch, it's 0 plus 10. That adds to 10. I would put a check mark under that branch, because if I walk down that branch, it's 5 plus 5. That adds to 10. And I would still say 2 out of 9. Okay. Example 3. Here I gave you the sample space of a deck of cards. Folks, card questions are going to be asked of you. You need to get at least a little bit familiar with what a deck of cards looks like. So one card is drawn from a well-shuffled deck of 52 cards. Use the graphical display of the sample space to find the probability of getting. Connor, can you read A to me, please? Take your pencil. Now, I'm going to use red as a color. With your pencil, circle the red cards. I think the red cards are diamonds and hearts. Yes? Probability of how many red cards are circled? 26 out of how many possible outcomes are there? 52. By the way, I know that reduces to 1/2. I'll reduce at the end if I have to, but for now, this is telling me, hey, you got 26 successes out of 52 outcomes. Brooke, what are the odds? The odds would be 26 reds to 26 blacks, and that would reduce to 1-to-1. What we call 50-50 in slang. Okay? B. Cole, what's B want me to find? I'm going to go black for Jack because it rhymes. Circle the jacks. Yes? The probability of a jack, how many jacks are there? Out of 52. Again, if you want, you can go 4 fraction 52. It's 1 out of 13 because there's 1/4 of the deck is, 1/13. There's 4 jacks. What are the odds? 4 to 48 or 1 to 12? C. Christina, what does C want me to find? What's the probability of not getting a jack? How'd you get to 48? Did you guys actually count? What did you do? Okay, guys, you with me? Okay. There's a fancy name for that. It begins with the letter C that I introduced to you last class. Sorry? The complement. Okay? You used the complement. You said, I could count all 48, but wait a minute. If I know the odds of something happening, I automatically know the odds of something not happening. As a fraction, it's 1 minus. So as a fraction, it's, don't write this down, 52 out of 52, take away 4 out of 52. Or just as a number, it's 52 take away 4. So you said the probability of not getting a jack. Now remember, here's our notation. We said this. How do I show not a jack? 48 out of 52. 12 out of 13 in lowest terms, but I really don't care. Rachel, what's D asking me to find? A red card and a jack, a red jack. In other words, at the same time. See what we've circled? What's in both circles? How many? 2. Do you see it? There are 2 cards that have been existing in both circles. Probability of red jack, 2 out of 52. The word and in probability means both at the same time. So it has to be both red and a jack at the same time. The trickier one is E, because E, the word means different than in English. Emma, can you read E to me, please? A red card or a jack. What's the probability of getting a red or a jack? Now, here's the problem. Jordan, in English, if I have 2 chocolate bars, if I have a Hershey bar and I have a Mars bar, and I can say you can have the Hershey bar or the Mars bar, in English, you don't get both. Or means one or the other, but not both in English. In math, in probability, the word or means one or the other or both. In other words, can you read this to me again, Emma? What does E say? Just read to me exactly what it says. That's going to be 1 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. It's going to be 28. There's a faster way to get there without counting, but for now, or means one or the other or both. So, a good way to visualize this using those circles is with what's called a Venn diagram. A Venn diagram is just a picture that uses circles to represent separate groups. So I wrote down here related events, complement. The event that A does not occur is the complement and is devoted by not A. As a picture, we would say this. Here's the entire sample. Here's the entire sample space. Here's the event A. The ones outside the circle, this is the event not A. The event A and B, that's both occurring at the same time. If you're talking about two separate events, in terms of a Venn diagram, it's where they overlap. It's where they overlap. The event A or B, and this is where it's different from English, Jordan, means one or the other, or both where they overlap. Say, what? Well, it's easier if we look at some examples. Here's a sample space for rolling a black die and a white die. By the way, looking at this, how many outcomes are there? 36. What's going to be in the bottom of each of my fractions? 36. Okay. It says the black die and the white die are rolled. Consider the following events. So event A is the sum of the two die is at least 9. Event B is the black die is one less than the white die. It says use the sample space to find the following probabilities. You know what? Since we have a sample space, let's use that circling trick again. I'm going to make a little note because I can go multicolored. I'm going to do event A in blue, and I'm going to circle event B in red. So let's start out. Event A says the sum of the two die is at least 9. What does the word sum mean? What does the word sum mean? Add. So it's saying if you add them up, you get an answer at least 9. 9 or bigger. I think here, yes? Here, here, and here. Those all add to 9. Oh, and bigger. Here, 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 here. I think the bottom right corner kind of. Event B is the black die is one less than the white die. I better figure out what comes first, the black die or the white die. Looking at this, it seems to me, since this is a 2, and they wrote the 2 first, you know what? The first number is the black die. So I want that the black die is one less than the white die. Here, 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 and here. Yeah? 1, 2, 2, 3, 3, 4, 4, 5, 5, 6. That's where the black die is one less than the white die. You okay with that, Colin? Okay. Now let's answer the questions. What's the probability of A? Well, first of all, there is 36 possible outcomes. In how many of them is the sum of the two die at least 9? You know, you should have circled on your own paper and you can count in front. I see Seb squinting at my screen, which is fine, but you should be able to look straight down and count, yes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yes? What's the probability of B going to be out of 36? Because there's 36 possible outcomes. Sorry? 5? What's the probability of A and B? Now remember, and means both at the same time. How many belong to both sample space, both subgroups, both events at the same time? 2? A or B means one or the other or both. Or in other words, how many things are circled? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Is that okay? Yeah. Ah. What's the probability of not A? What's the probability of not A? 26 out of 36. Did you count? Or did you use the complement? Who said 26? Is there? Did you count or did you use the complement? Yeah, right? 36, there's 10 that are successes. 36 must not be A. Sorry, 26 must not be A. Oh, in words, what does the event A not A represent? Sean, can you read to me what the event A was at the top of the page there? What did that represent?
The sum of 2 dice is at least 9.
So what would not A be in English? I'll give you a hint. The sum of 2 die is? What's the opposite of at least 9? Or you could have said 8 or less. Sure. That's what the complement represents in English. If we're talking about weather, if we're talking about the weather, what's the complement of sunny in English? Cloudy, rainy, right? If we're talking English, what's the complement of daytime? Nighttime. Okay. So I will on your test actually say, hey, can you translate this into English? I'll give you an event and I may say, all right, in English, what does the complement mean? What are they asking? Venn diagram. Example 5. If each of the 13 outcomes in the sample space is equally likely, find probability of A. How many outcomes? 13. What's going to be in the bottom of each fraction? How many outcomes? 13. What's going to be about 13? This is why I said, Rosanna, in the last lesson, if you can count it, you can solve it. So probability of A is going to be out of 13. Why 4 and not 3? There's the circle. How many events are inside circle A? 4. What's the probability of B? It's going to be out of 13. 5, not 4. What's the probability of not A? And you could also have gone 1, 2, 3, 4, 5, 6, 7, 8, 9 and counted them, but hopefully you used the complement. What's the probability of not B? What's the probability of A and B? Or let me ask it a different way. How many dots are in both circles at the same time? Just one. See it? See it? There's a picture of and. And means both at the same time. In fact, Sean, you'll often hear me call and the overlap. It's where they overlap. What about A or B? Now, A or B means one or the other, or both, unlike in English, where or just means one or the other exclusively. A or B in probability means one or the other or both. Oh, it's going to be 1, 2, 3, 4, 5, 6, 7, 8. That's how many are in A or B or both. Justin, can you read this next one to me? You're zoning out. Look up. Yeah. I know my audience. This one here, I'll give you a hint. The P stands for probability. What does this bar stand for? What do we say when we see that bar, folks? Not. Okay? So this is saying, you with me now? You back? You back?
Yeah, I'm back.
Okay, this is saying find the probability of not A and B. You know what? This is saying find the probability they don't overlap. How many don't overlap? 12. 12. 1 overlaps, 12 don't. Next one is the probability of not A or B. So A or B was how many were in one or the other or both. What's the probability of not that? How many are not in a circle? And you could get there by the complement or by counting. See it, Kevon? I'm almost certainly on a quiz or on a test going to give you a Venn diagram like this and give you several questions like this. Because it starts here and then we can broaden it. So, homework. Says packet 1 contains an orange, can we, do I want to do number 1? Sure, 1 is good. Skip 2. 3 is good. Four is good. 5 is good. And I did attach the answers. It's not your imagination, and there's a very good probability mathematical argument that makes this work. So write this down on the very, very back of your notes. The heading is, why the other line moves faster. Psst. So on the back of your notes on the blank page. Okay. And let's consider a situation where you have one line on either side. So let's consider the situation where you're looking at 3 lines, and you're in the middle. Okay? As a tree diagram, it would look something like this. Okay? Let's assume, just due to randomness over time, that the odds of one line being faster than another line are all the same. Each of these is equally likely to be the fastest line. Okay? How many outcomes are there? How many branches are there? 3. Probability that me is the fastest, it's going to be out of 3. How many lines are you in? The probability that you're in the fastest line, if you look at one line on either side, is just 1 out of 3, which means what's the probability of not the fastest? 2 out of 3. It's not your imagination. 2 out of... Now, here's the problem, Rachel. We don't notice if we're the second fastest. We never notice that. All we notice is that a person that we used to be level with, we're no longer level with. We notice this bottom one when we're not the fastest. And I'm sorry, if you look at one line on either side, 2 out of 3 times, you're not going to be the fastest. Probability. It gets worse. Gets worse. What if you're in a bigger checkout area and you've got 2 lines on either side of you? Uh-oh. So we have something like this. 1, 2, 3, there's me. 4, 5. What's the probability that your line is the fastest line, assuming it's random chance, which it is over the long haul? What's the probability that your line is the fastest line now? 1 out of 5. So what's the probability that you're not the fastest? 4 out of 5 is a decimal, is 80. It's 0.8. It's 80%. You know what? If you're someone who looks more than one line in either direction, you're just making it worse. And it's not your imagination. But part of the problem, Justin, is we never notice if we're the slowest line. We only notice if we're not the fastest line. And if the odds of not being the fastest line are pretty high. So you're not going crazy. You're not someone who always looks at the glass half empty. It's actually mathematically provable. Who knew?